My name is Yuan Ma, and I'm here to present my proof of concept, the AI-powered data analysis assistant. The problem I wanted to solve was simple. How can we use AI to intelligently automate the data analysis process? I envisioned a system that could take a raw data file, like a CSV, and autonomously perform critical functions like inferring its domain, identifying common analytical tasks, and generating initial insights. That vision became the foundation of this project. This project is built on the idea that LLMs can act as cognitive agents because they excel at natural language processing. They can understand the language of data and code. For example, an LLM can interpret semantic meaning from column headers, inferring a retail domain from terms like product name and price. This same capability allows them to synthesize Python code for analytical tasks. Let's look at the core modules of this assistant. The process begins with the schema inference module. Once a user uploads data, it automatically detects data types, infers the domain, and flags quality issues like missing values. Next, the analyst planning module generates a list of relevant tasks based on these characteristics, saving significant manual effort. The code generation module then creates the Python code for these tasks, from data cleaning to visualization. Lastly, the quality assurance module evaluates the generated code, provides a score, and offers suggestions for improvement, acting as a crucial feedback loop. This slide shows a comparison of the data analysis workflow before and after using LLMs. As you can see, LLMs can transform 5 manual tasks and 3 script tasks into more efficient user or automatic service tasks. These screenshots illustrate the core capabilities of the assistant. On the left, we have the initial data overview, including the inference domain and analysis suggestions. On the right, you can see the next steps, the generated code for a comprehensive data analysis workflow, from data cleaning to visualization. The architectural choices were crucial to this POC. I used LangChain and LangGraph as foundational frameworks to orchestrate these complex stateful AI workflows. Gemini was chosen as the general-purpose LLM to brainstorm and understand the typical flow of data analytics tasks. For code generation, I specifically chose Quellcoder because of its fine-tuning for high-quality Python code. Finally, FastAPI provides the REST API layer, ensuring efficient interaction with the assistant via web pages. To validate the solution's versatility, I tested the assistant across a range of synthetic data domains: healthcare, retail, financial, and education. This broad testing confirms the foundational robustness of our approach. Like any POC, This implementation faces significant challenges, such as code reliability. Not all generative code consistently executes without errors, and semantic accuracy inconsistency, especially with ambiguous or complex datasets. Limited error handling for unforeseen edge cases and scalability remains untested. It remains untested under high computational load. Despite these challenges, the implementation successfully demonstrates its core functionalities: analyzing data, generating and executing Python code, and producing tangible analytical output. Here is a closer look at the outputs. On the top left is a sample of the generated Python code for data cleaning. The other visuals are just created by the executed code, including distribution blocks, correlation metric emails, and histograms. In conclusion, this POC demonstrates both the immense potential and the inherent challenges of AI-assisted data analysis. It opens up exciting discussions about how AI can truly empower data professionals, making their work more efficient, insightful, and ultimately more impactful. Thank you for your time and attention.